So this is going to be about Leo. Leo's this open source software that can be used for an IDE, and that's basically what I'm going to be showing you here. What attracted me to it in the first place was, it's like, hey, you know, with this I could like program in the way they were trying to teach me to program in school. So it had some attraction there. You saw it on the screen when you initially came into the room, and we'll be looking at it again. So, entitled it, A Shift in the Paradigm. So, what am I talking about here? Well, Leo's about organizing mostly. And really the atomic level of organizing that's actually physically supported by something real is files and file names. I mean, when you start coding, the only real structure that you can impose that's real is, naming your files so they give you some hint of what might be in them, partitioning your code up and putting it in files like that. So that's the only thing that's real. But, there are other things you can do. There are other things you can do. Okay, so for organizing below the file level, you can put in section comments. Okay, in this section, I'm going to have initializing routines. In this section, I'm going to have whatever, like that. When classes came in, that was another way to organize your code. You could organize things by function. You could put them in relationship to things that, might have a more physical existence, and putting your functions and methods under that. Then that's kind of textual division. And there's also like some organizing by using composite names and whatnot. So like I said, this new paradigm, it's going to be about organizing. So what Leo's going to provide is a new real division that exists below the level of file. Something called nodes, and we'll get back to that in a moment. But first, let's look at some of the current tools. Okay, so you got to manage code. I mean, what tools do we have currently? I mean, we have code browsers. Some people use folding editors, to get the stuff out of the way so they can just concentrate on what they've got open and fill in details there. Most of these, the programmer itself has to use their own memory and whatnot to, navigate through here. It's got to have some idea of what names he's used so we can, regex search for them and just get to the right place. Another tool we've got are code calls and code completers. That's nice because, it's hard to remember how to type all these things. All right. So some of the limitations here is, there's no formal way of, capturing when you shift details. We're all coders, so, we're like drawn to like, okay, let's start coding, and we start writing code, and it's like, oh yeah, I'm going to need a method for this, so we got to pull back out and maybe make a note of that and remember to go back to that. Some people use to-do lists and things like that inside the code. Some editors have supports for do lists and whatnot. But that's all, handled by our heads mostly. And I mentioned just, section commenting. Well, that's nice, but, just like regular comments, they often get out of sync with what you're trying to do. I mean, you come up with these divisions and you're just adding routines and functions and whatnot into various sections, and sometimes they don't match up anymore. But it's so expensive to go back and think about it and move things around that we don't really do it. So they get out of sync just like regular comments do. And code browsers, they're good, but they're strictly based on text parsing and for features in your code, and there's language specific, because they got to know what patterns to look for. All right. So I mentioned these node things. Now, what are these node things going to give us? These are what are going to give us the division below files that are going to be real, in a sense. And then they're not going to be textually defined. They're going to be supported by Leo. It's a new way to organize our code through outlines. And I don't know the outliners that are that popular anymore, but it was an early on application that saw a lot of use. People, use outlines to organize their thoughts, organize their to-do lists and that sort of thing. It was, there was a whole bunch of them back in the DOS days and whatnot, and there's still quite a few left. There's some in the Mac world that are very popular, a few in the PC world, but they've kind of fallen out of favor. But the creator of Leo, he was aware of a particular outliner on the Mac called More, and this is what inspired him to say, hey, maybe I could use outlines to program. So they also provide a new way to navigate through our code. We're not bopping around using regexes anymore. We've got another level to navigate through our code. And it's an explicit way to vary our attention because, you have to manage complexity. And then what's the rule? 7 plus or minus 2. Those are all that the human mind can hold in your head at once. And you've got to be able to chunk things down and deal with them at higher levels than just the detail of line after line after line after line after code. And that's what Leo will give you. And again, it provides a formal way to quickly capture your design at the large level and at smaller levels. And it's cheaper to reorganize code because an outline, you can drag the things around and put things in the sections that make more sense. So it's much cheaper to reorganize your code and things don't get out of sync as badly. All right, so Node. There was going to be a movie here. But I'm actually going to demonstrate physically what I'm talking about. A good mental model for codes is an index card, and I think these are you're still probably familiar with these. They haven't completely disappeared and whatnot. An index card has a place for your headline and a place for your body that supports that headline. So what Leo does is it separates the two. You take away the headline and you deal with that separately, and then you've got your body code. Might have worked better as a movie, but hey. So that's the idea. We've got the headline to deal with, and then we've got a body where we're going to put our code, and we can deal with them separately this way. But they're still linked together. They will be in Leo. I mean, this is really a model. You've got your headline, your body text, and the other thing that Leo stores with a node is its position inside your outline. So that's the movie that isn't there. So, screenshots. Well, actually, this isn't so good. Leo uses Qt, and Qt adapts to whatever operating system you're under. And if you notice in the pane up here, it's using tree view, but it's a tree view from Vista or XP, with the pluses and minuses and whatnot. And so it doesn't really look like that anymore. So let's just go right to the application and look at that a bit. So here is an outline in Leo. It's got 3 panes, basically. Well, 3 panes. This pane here is the outline pane. And you can see the headlines are in here. This is the body pane. And all that appears in here is the body text for the selected headline. So this will vary as we go through it. And then over here we have what's commonly referred to as a log pane. And here we just have text generating events that have happened in Leo. So the only thing that has happened here is it started up, and it reported on what's running under, and it read in the file that is going to hold this project. And we can think of this as a project file, with the .leo extension. Now this file is available here under the help menu, and it's meant to be a quick demo of how to use Leo. So it's called quickstart.txt. I already loaded it in and renamed it. Plus I made a few tweaks to it because there's some depreciated language in that file that hasn't made it into the changes and whatnot yet. But let's start using this, and let me demonstrate a little bit of what you can do with Leo. So the active pane will be highlighted in red. Nothing's really active at the moment. See what red here? Now, the arrow keys will navigate through this. And if I just hit Alt with an arrow key, no matter what pane I'm in, it'll go back to the outline pane and start changing things there. And once you're in that pane, you can just use the arrow keys without the Alt modifier. So, like it says, you can usually ignore that. It's just a little welcome. And notice how the body pane is changing as we go into here. Now I want to demonstrate, our objective is to get programs, and to do that, we're going to have to generate some files. So that's contained in here under programming. And you might notice that there's no little dot there. Let me go back and give you a mental model for what's going on in this outline pane. Notice we have a little rectangle there. And sometimes it's got other things in it, sometimes it doesn't. There's a physical model for this that I tend to think visually in visual metaphors, so let me give you my particular metaphor for this. Okay, the metaphor for me for that rectangle is a table, a chair, maybe even a programmer, because one of the things you can do with Leo is you can assign different parts, map out what somebody's responsible for at a higher level, and then let them go off and code it. So, it might not be you who's filling that chair to write code sometimes. It could be other people. But if it's you, it still makes sense because you're actually time multiplexing yourself and varying your attention. So sometimes, you're just looking at things at the higher level. Sometimes you're actually sitting down and programming. So a blank table, and then sometimes something's on it. Well, there's a square on that, and that represents the body text. And it's really only there when you've written something in the pane, kind of like this. Until you've actually filled something in the body text, you don't have this square. Once you do, you get a black border that indicates that it's dirty. You've got unsaved changes. And once you save, you lose the black border and you're back to a table without the border. All right, so that's just my metaphor that I use. Let's go back to this. All right, so here we can see the rectangle. It has no square. That means the body text is empty. Let's open it up. Now, if we just do, it's rather intuitive how you open these things up. We're used to tree browsers, so this will just open up with an arrow. Now, what programming did, actually, what it was saying as a comment was, everything that's under here is going to have something to do with programming. And we only have one descendant at the next level. And what we're going to be talking about here are external files. That's what we want to create. You know, there might be C files, there might be Python files. This will also handle our RST files easily. In fact, it'll handle a lot of different languages. They have to have the parser and a syntax colorer to be added, or if it's not already there, and then you can handle another language. So let's open up this. All right, so here we've got 4 different ways to create files. And the first 3 of these are going to write out a program. It's actually the same program. If I opened up each one of these nodes, you'd see the same thing underneath it. So I'm not going to go over the first 2 because they're actually both created by shadow nodes too. And so let me talk about them so you can get some feel for what goes on there. So let me open this. So now, this is our first directive. Now directives are kind of inline instructions to Leo to do something. And there's some directives will only appear in headlines, some will only appear in body text, and they'll do different things. This path directive is all it's saying is, okay, whatever file names get created underneath me, put them in the home directory. I mean, this is more Linux context, using the squiggle for that, but this will be the user's directory basically, and that's where the files will end up. So let me just open up all the levels under here at once so we can look at them. All right, so this is our program. The next command here is the one that's actually going to write out the files. But it's currently in a commented out form, the double @ in front, so it's not enforced yet. So when I open this file, it didn't do anything. If this had been removed, Leo would have gone ahead and done something. Let's go modify it. It's Control H to modify a headline. Let's go to the home on that line and delete that @ sign. All right. So now this line will be active. Now it will only execute when I do my next save. We'll see that in a moment. First, we got to go on. What's in the body text here? Well, the way Leo works is kind of like old mail merge documents and whatnot. We actually have a template that's going to put together the file that gets written out, but it's instead of like going out to a database and doing first name, last name, like that, it's actually going to go into the sub outline or the sub tree of this. So all the code is included in here. And we see some directives again in here. Language is Python. That's how you handle multiple languages. All you would have to do is have a different language, at language C, C++. And then the code would be, beneath that would be colorized with that particular syntax editor, and the comments would be use the right commenting characters and whatnot. It's the @others that actually is part of the template. What that's saying is, okay, go out and go through the subs here and start pulling in what I need. And one of the nice things about Leo is, commenting is more built in. It's harder to get out of sync, much as with section things. And I mean, because we're like organizing, we're using outlines to organize things. So the next thing here, you see there is no body text. They're actually using this as an organizing node again. It's saying, okay, what you see underneath me, they're going to be imports and setup routines. And if we go down, we see, okay, here are our imports. And here are a couple initialization routines. Now the @others will basically start transversing this tree. It'll go down here, see there's nothing to pick up off of that card. Okay, there are 2 statements to pick off of this card. And what it actually does, it takes these and it puts them at whatever level of indentation the others is on. So this started at 0. It's going to put the statements, the import statements, at column 0. Here are the inits. They're also going to go at column 0. So it's done that. Now it's going to look, is there anything else to pick up? Here's a class. Well, the class actually has another @others, so it's going to stop the original @others and say, okay, now this is the next part of the template, just append me. So the class foo gets appended, and here we introduce a new concept. He says named subsections, doc string with the double brackets. That's saying look for a headline of that format and just take the body text and replace it there at this indent level. So there's the class comment. Here, the @others in that template at the class foo level is going to pick up this definition for spam and this definition for eggs. Okay, well, let's save this out. I only did that because I ran this previously. All right, so you see over here in the log pane, it actually, well, there weren't any changes, but if those files weren't already in those places, it would have written those files out there, and you would have seen saved, 3 saves, and like that. So this shadow node is actually saving 2 files. And let's take a look at those with a different editor. Oh. Okay, so here's what saving would write out. Here's our whole program. And I named it my program _ shadow.py just because we're using a shadow node. Like I said, the other nodes above it are the exact same program. So there that is. Let's go back and do a change. Oh, didn't move. Okay, so I swapped spam and eggs to, it's now eggs and spam. Now if I do a save now, notice we've got the black border. It wrote both files this time. And if we go back to Vim and look at that, you'll see that it's noticed that this file has changed. And now,
what's with the dollar signs at the end of the line?
oh, sorry, that's Vim. It's just showing me the end of line character. Probably should have turned that off. But we now have,
I think you need to reload it.
it doesn't, does it?
I think you swapped it twice.
Yeah, I think so.
Yeah, that's probably what happened.
Try hitting F5.
No, I'm probably, let me look. It is of what eggs and spam should have, yeah.
I think you wanted spam before eggs.
Well, that's, well, hold on. Let's look again and see what it actually says. We've got spam and eggs in the code that was written.
You wanted eggs and spam, so you need to refresh it.
Well, let's see. It should have. Well, no, it just saved that. Yep.
Is that Vim?
It is. colon E what?
Percent.
Percent
Goal, that'll just reload it.
gold bat?
Exclamation mark.
Oh, bang. Sorry, different errors.
Colon E.
Up. Ah. Swore I'd type that E.
Percent will work too. No, no space if you use a bang.
All right. So, I'm still learning, Vim. But there we go. You've seen that we're able to just swap things around. So it's, like I said, it's good for reorganizing things. All right, so let's then talk about the downside and why we actually have this shadow node. Now, when I said that Leo introduces another level of below a file, these nodes, there actually was no provision for that, in editors. I mean, so Leo actually creates two files when you're doing shadow. So to actually support these, we actually have sentinels in our code in a file that keeps track of this. So these are, like opening, closing tags in HTML. They're, they're not pretty to look at. You basically don't want to look at. But actually with them in here, you can go in and edit the code in an outside editor, and they'll pretty much won't mess up your outline. So if this shadow stuff is really to make it easier to play with play nicely with other programmers who have to look at your code and they don't really care for Leo, they don't use it. You've got the the plain unsentinel version, and you've got the sentinel version that in a hidden place that Leo will read in order to repopulate all the outlines. So, how am I doing here? 3:30. All right. So let's go back to the presentation a bit. Okay, so I talked about the path. So now that you've seen it, what does Leo bring you and what advantages do you have? Okay, so you saw in Leo you can set up a correspondence between files in your project and files that externally exist on your hard drive and the outline itself. So you notice there that our code block, it looked like half a page. I could have rearranged things so you had more, but one of the things you want to do in code is you want to write smaller pieces and whatnot. And one of the nice things about Leo is it lets you chop things up into fairly small pieces, that cluster, and you can name in a way that you're like, oh, this right now I want to do this, in my function. If you need, if it's going to be some super long function, you can like chop it up, give it names, or not even bother giving it names, but you can still chop it up. So it helps keep your code blocks small. In fact, some people use this for writing assembler and whatnot, and it's really useful there because, in the assembly, all you've got is a list of opcodes and that sort of stuff, and it's like real easy to lose track of, okay, what am I trying to do now? If you're writing yourself little notes in the headlines, you can handle pretty complex concepts by keeping them small. Okay, reorganizing is easy despite the little bobbles I had. You can drag things around. Some of area, like the section comments, you still have the ability to do like section comments, but it's easy to like, okay, well actually this function should be over here, in this section, and this function should be over here in this other section. So it's, or, okay, I'm seeing a new class of things that are doing different tasks. Let me create an area for that and start putting them in that area. Okay, so it also supports the coding shift, large to small. I mean, there are functions in Leo that let you go to a body text, write a whole, return separated list of headlines, and then have them sucked out and put into their own nodes, and then you can start filling in that. So you can quickly design a whole list of different functions, whole list of different methods quickly, and then fill them in later. It's like, okay, I'm going to need to do this, this, and this. I'll get back to it later, but here they are stored, so it's not all up in your head. So, like I talked about, hard tasks can be further decomposed if you need to. I mean, when you're starting out programming, you tend to write a lot of comments, and then as you go on, it's like, okay, I know what I'm doing. I've done this before slightly differently. I don't really need the comments. So you can vary the level of decomposition that you need that support you in getting your tasks done. Okay, outline structure works as commenting. Let me show you a bit of that in Leo itself. Yep. I never understand why they don't do cascading menus the way Apple does. I always run off the wrong end of these. Okay, so Leo, like I said, a .leo file is pretty much like a project file where your project meta details are stored, but it can include references to other files that it'll read in to build the outline out of all those sentinels. So this is the file that generates the entire application. And we'll let that work a while, because it's got to read in a lot of files to do this. Let me go back to my presentation, and I'll come back to this point. Okay, custom task-oriented side views. One of the hard to get things that Leo offers is it's not strictly outlines. It's got a concept where you can reuse subsections of your outline any place. You can basically, it's as if you were to take the subsection of an outline, put it in its own room, and then you have, and I like the game Portal and whatnot. It's like you can create different entrances to that same room from different points in the outline. So you can use this to support your programming by, let's say you've got a bug and you know it's likely to involve these different routines. You can create a outline that lists that particular bug, and then you can start pulling in all the code that you suspect might be part of this problem, and just put in portals into that code where it's being generated out of a file underneath that, and then you just deal with the changes there, because any change made, they're called clones. This is kind of unfortunate because it's not a clone in the sense of a twin. It's actually the same object. It's really more a cloned entrance into that code. So once you've gathered them someplace else in a custom view, you can make all your changes in there, and they're automatically reflected back in the files that will be used to create your external files. So let's see if we've...
Like symlinks?
Like
Symlinks?
Yeah, actually people have used that analogy. All right, so should have read it more. So here is the core classes in Leo. They're organized, as I was talking before, you use file names to, section off functionality. Now, one of the functionalities that Leo needs to handle commands. In fact, there's an object for each tab called a commander that's in charge of, running the application for that. So let me show you Okay, so here's it's a template for files. It's going to do the imports. It's a named section, and there'll be under the import there. And then it's got just two classes. We'll look at commands. Now, there are a whole lot of commands under this. I mean, I've looked at I've always been interested in UML tools and that sort of thing. But when I applied it to this class, it was so long that it was, there's just so many methods under commands that it makes no sense. But Leo has the ability to group those. Here we got birth and death. So it's got a bunch of methods under there that are each defined in their own slight box, their own code blocks. And yet we were able to use Leo to organize all that. These are individual commands. These, any place where there's a wedge that reveals more, usually is defining multiple commands, and it's just grouping them by, common functionality. And this is serving as a cheap way to comment things, which, like I said, it's harder to get out of sync with. Okay. Now the other thing is, outline nodes become data. It's Python. And there are a lot of helper methods that are available to you that will go out and take this data in the nodes and process it any way you want. You can write your own little mini macros that are very powerful. A good analogy is it's kind of like a spreadsheet where instead of cells, you've actually got trees of data that you can iterate through and use to calculate results. And there's an example of that in the quick start. I don't know if I'll have time to get to it. So like I said, you can write your own macros and you can do very powerful things. Okay, the other thing is it's extendable beyond just text. People have used this to use restructured text and whatnot. It's really nice for that because you've got all this tools to rearrange and reorganize your notes and whatnot, and it's very powerful. Now you need to have a restructured text tool chain installed, and there's a plugin that you need. Well, actually, it's activated automatically. It's one of the standard plugins. But then you can deal with documentations and things. So, all right, let's see. I guess I didn't open that, did I? Great. I've been hijacked by several search engines recently setting this up. So for example of, oh gosh, thank you Google, here we are. All right, so this is Leo's homepage, and it's restructured text, and it's actually included along with Leo. So you could set up your tool chain and build Leo's documentation. Let's go just to the user manual. So this is maintained in a Leo outline and generated whenever we need to regenerate the file whatnot. And it goes, custom topics like, installing Leo notes, that sort of thing. And you see that this is a fairly nice layout. Let's go back there. All right, so I think we got a little bit more time. Let me go back and maybe demonstrate programming. Scripting Leo. Okay, so we can talk about custom micros. Here we've got a micro that's going to deal with the current node. And if I do Control B, it'll execute it. All right, and you see, where did the results go? Well, there's actually a script in there that says, go ahead and put the result under here. So it generated a report. And what did it do? It actually pulled out all the headlines in this outline. And there's a lot more meta processing we could do with that. There's also script buttons. So up here, there's a button that says script button. And what it does is it will create a button of that title, example button, and put it in there, and then it will operate. Now, this was actually created when this file was first read in. That's why it's in here automatically. And all this thing is doing is it's looking at, okay, what's the current outline headline? Well, what's the current node? Give me its headline, P.H. P is for like the current position. You've got a lot of nice shortcuts built in that help you operate with things. So all it is giving us the headline for that. So it's saying, hey, configuration, enable plugins, etc. is on that. So that's an example of what Leo can do. It can also be extended to deal with other things. Some people use this. I mean, it has the ability to add arbitrary blocks of code or of data. Some people use this as an outliner. Let's see if like a to-do list. No. Task status. Anyway, I won't get to it now, but you have the ability to like put in custom icons, priorities and that thing. If you were using this as a to-do list organizer. And I mean, there are a lot of plugins to deal with special things. Some people use this to interface with databases, send off SQL inquiries, get them back and store the results and whatnot, kind of like a notebook, that sort of thing. So let's go back and let's take some questions if there are. Yes?
What if you want to do something like view a function definition and a call to it?
And the call to it.
Can you read the question?
Yes. The question was, what if you wanted to view a function and look at the calls to it? There are plugins, and Leo has its a really nice Python plugin interface that handle completions, and they also will let you store, parse out function calls so it can provide, you a method to that. But as far as going through your code and actually giving you the function calls, I don't know if that's built on yet, but it's something to be added to.
I'm talking more of like a split screen kind of thing, where in my normal text editor I do a split screen and on probably the same file or two different files, move to the function definition.
And like that. I mean, there is support for multiple editors opened onto different places in the outline, but probably not quite what you're talking about. But it's not that old a application. There's still a lot of things being added. I mean, there's a lot of excitement about some new ideas like Lightbox and whatnot. And we were just talking about it recently. It's like there's nothing in Lightbox that couldn't be added to Leo, you know, and it probably might even be better in this format because, like I said, you can deal with things at a much smaller level. Yes.
How does this fit into a programming environment? Things like make files, or having things on GitHub, and in particular working with other people who might not be using Leo?
Well, that's what the shadow node was for. So you can share the files that have no sentinels in it, and they can just look at it. They can make changes into it, and they actually can be read back into the outline. Now, you may have to play with, you know, where things get put, but they will actually go back into Leo if you do your editing externally and whatnot. As far as GitHub, it's written so that changes that you make, you know, have minimal impact with your versioning system. So you're not, every time you do something, you don't generate a lot of extraneous changes, that sort of thing. But, you know, it's still something to be worked on. Somebody was just recently writing a little plugin that would, you know, diff things at a Leo level, so you could see, you know, this is how it was originally, and underneath it is a note of the difference, like that. So still evolving, but there is provision for some of that. Kathleen?
I was asking about collaborating with people who aren't using Leo, and if you're opposed if they make edits, but
I mean, it needs more work. Ideally, I mean, I can see this being fairly useful to an open source project if people were all using that, you know, and you kind of get mind share. But there are provisions for doing that. I mean, there are people within companies who they're the only one who's using it, so they're, you know, sharing off their files but without the sentinels, you know, and then other people make changes. It's read back in. You're able to look at it, annotate it in a way that makes sense to you, and go on. Oh, yeah.
If they edit a file, the shadow file, and they rearrange pieces of it, is Leo smart enough to rearrange them back into the file with sentinels?
It's probably not 100%. You know, you probably would have to go in and, you know, look at it and say, okay, there's some changes here that aren't really reflected in the way that I'm organizing things. But it does make attempts to do that sort of thing. You know, it's got an algorithm. I mean, if the add auto node that was in there, the add auto node, it goes out and reads a raw file basically without any sentinels, pulls it in, parses it into an outline just using Python or whatever language you're using, you know, the rules from that. You know, classes at one level, subfunctions at another level. And then you can, you know, rearrange things and add nodes and whatnot. But when you write that out under an auto file, it's just written out as another sentinel-less file. And so you lose all that. The next time you open it, it would reparse that file, that raw non-sentinel file. So that's one way that some people work with that. All right. I guess my time's up. Thank you.